Welcome to the lecture on writing MATLAB functions. In this lecture, we are going to have a deeper look at writing functions. This is the MATLAB function syntax we've known so far. Okay, so the function header goes function, output argument equals to function name, and input arguments. Although this syntax is straightforward, I still see a lot of ambiguity when you write functions. Okay, so when you write a function, you have that header, and then you do something with the input arguments, evaluate the output argument, and then end the function definition. If you're still confused on how to write a function header, think of it this way. Okay, so if you're calling that function on command prompt, you would have the output argument to the left, and then you have the input arguments in the parentheses of the function. Okay, so let's look at this typical function rand. So for using rand, we don't even have to have any input argument. If I just say val equals rand, you'll get a value that is between 0 and 1. All right, so let's look at all these function calls which we have seen so far in the semester. One common thing about all these function calls is that you have only one output argument, although you have different input arguments. So that way we can classify, the MATLAB functions into functions that calculate and return only one value, functions that calculate and return more than one value, such as the MATLAB inbuilt function size, which returns two output arguments, rows and columns. And also we have functions that just accomplish a task, such as printing, without returning any values. These sort of functions are very handy if you want to remove the clutter in the main script that you write. We're going to see a bunch of examples in this lecture. Let's have a deeper look at the functions that will return more than one output variable. The syntax for such functions looks like this. So where you have function keyword followed by output arguments, which are placed within square brackets. Okay, so that's the most important part of the syntax, the square brackets, and then you have function name followed by input arguments in parentheses. Now, once you have written this header, the next thing is to do something with the input arguments that you have and evaluate each and every value inside the output arguments. And finally, you end the definition of that function. To demonstrate, let's write a function that returns diameter, circumference, and area of a circle given radius. So I start with function, square brackets, diameter, circumference, and area equals to dca underscore circle. So that's the function name that I've given. And then the input is radius. Now, my task is to evaluate diameter, circumference, and area from the radius that is given. If you observe closely, MATLAB editor is underlining these output arguments as well as input argument in this orange funky line. There's a reason for it. Okay, so the moment I'm evaluating the diameter, you see that the orange underscore line is gone for dia variable. Similarly for circumference as well as area. At this point, you see that the underlining is still there for radius variable. That's because instead of using that input variable, I've used r. Okay, so let me correct that. So I'm going to change r to radius, and you'll see that that prompt is disappearing in MATLAB editor. So something to keep in mind when you're writing functions, make sure that there is no orange underscore for any of the variables that you're using. All right, so let's see this function in action. So the first step is to store it. So it's storing it with the same function name. Never ever run a function using that run button. The problem you'll find is that, it would run the function name without any input arguments. Now, anyway, so let's run this function, giving the input argument for radius, let's say 5. Okay, so I'm evaluating the diameter, circumference, and area for a radius 5. Now, if you observe closely, this function has returned only one value. All right, so it was supposed to give three output values, but instead it gave only one output value. And there is a reason for that, because you haven't used the exact syntax for, using this function. So the exact syntax is you have all the output variables within the square brackets. For instance, here we have three output variables put in square brackets, and then you call dc underscore circle of 5. That way it captures both diameter, circumference, as well as area in those respective variables. Now there are other variants of using this function. So instead of 3, if we just use 2 variables in the square brackets, it's just going to give you the first 2 output variables, okay? Anyways, if you give only 1, then it'll capture only the first output value. To summarize, stick to the standard convention of using this function, use the square brackets, have all the output variables, and bingo, you'll get what you want. Okay, so the next thing is looking at functions that only print or display values. So let's write a function that takes diameter, circumference, and area as input arguments and just prints those values. The standard syntax for that is, just because you're not having any output, you're going to say function, function name, and input arguments. And within the function, you're going to display those input arguments. Now, let me show you a function example that just displays, given values to it. So I'm saying this underscore dca underscore circle, d, c, a. Now I'll write a bunch of display statements or fprintf statements, which print the diameter, the circumference, as well as the area of a circle. Hold on for a bit. Let me finish writing all these 3, and I'll show you how this function works. And then copying over that statement as well. So I finish writing this function. Now, because I already have dca in my workspace, so I'll directly call this function. I'll say disp underscore dca underscore circle dca, and then it's going to print all those 3 for me. This brings us to the best programming practice of writing modular programs. Let's look at writing a modular program, with the standard example we've been using, calculating area of a circle. To do that, we have to get the input, calculate the area, and display the results. We'll write a function for each task in this algorithm. The beauty of writing modular programs is that if you have 3 tasks to do, then you're writing 3 functions, and you'll just have to write 3 lines of code. Okay, so the first line of code is where I'm getting the radius and storing it in the variable rad. In the second line of code, I'm evaluating the area of the circle and storing the value in area. And in third line of code, I'm just displaying the area. Now, so let me just save this script as area circ underscore script. Now my job is to write all these 3 functions that I've used in that script. Now starting with function get underscore radius, because it gets the output argument of radius, so I write it that way. This doesn't require any input argument, so I'm not even bothering to use parenthesis there. So I've written a function that gets the input. The next thing is to evaluate the area. So standard function for evaluating area, saving it as area underscore circ, and finally displaying the area that is evaluated. So I would do function disp underscore area of area, and this doesn't have any output argument. All it does is printing the area of the circle. So I'm just going to do that and save it as disp underscore area. Now I can go back to my main script and run it. There you go. It just runs perfectly fine. Let me modify this to, print the radius as well. So I would do the necessary changes that way. And then once I run the main script now, it gets the radius, it evaluates the area and displays it in that fashion. Alright, so see you in class. Come prepared. Okay, see you soon.